Good morning, students. Today's class we are going to have a continuation of our previous class. So what did we learn in our previous class? We learned about what are fractions, how to find a fractions, what are like fractions and unlike fractions, and we solved a few problems based on the addition and subtraction of unlike fractions. We also saw what are the different types of fractions. And we also saw how to convert improper fractions into mixed fractions and mixed fractions into improper fractions. In this class, let us see in detail about mixed fractions. So now, can you all see this fraction on the screen? What can you infer? This fraction consists of a whole number and a proper fraction. This is what we saw as mixed fraction in the previous class. By definition, a mixed fraction contains a whole number and a proper fraction. A diagrammatic representation of mixed fractions looks just like this. In this diagram, there are 3 circles, each consisting of 5 segments. The first 2 circles, all these segments are shaded, and the third circle, 2 segments are shaded and the 3 are unshaded. So, mixed fraction for this diagram is given as 2 by 5. Where the whole number 2 represents the circles which are completely shaded, and 2 by 5 is the fraction of the third circle in which there are 5 segments out of which 2 is shaded. Now let us see addition and subtraction of mixed fractions. Let us see an example. There is a joint family. For the occasion of Pongal, all the members of the family decide to buy new clothes. For the 3 boys in the family, they buy shirt materials and they want to stitch it into shirts. Each one needs different lengths of shirt materials. These are the lengths of the shirt materials needed by each boy respectively. In these fractions, 2, 2 and 1 are the whole numbers, and 3 by 4, 1 by 2 and 1 by 4 are the proper fractions. So these 3 are mixed fractions. So how do we find the sum of mixed fractions? There are 2 ways to find the sum of mixed fractions. The first way is add the whole number separately and then add the proper fractions separately, and then we need to add both the resultants. The other way is we have to convert the mixed fractions into improper fractions, and then we need to add the resulting improper fractions. So, in this example, the 3 mixed fractions given to us are 2 3 by 4 plus 2 1 by 2 plus 1 1 by 4. Let us find the sum of these fractions in both the ways. The first method, let us add the whole numbers separately and the proper fractions separately. Adding the whole numbers 2 plus 2 plus 1 and adding the proper fractions 3 by 4 plus 1 by 2 plus 1 by 4. These 3 fractions are unlike fractions, so we need to find their LCM. Their LCM is 4, and finding an equivalent fraction for 1 by 2 we get 2 by 4. The other 2 fractions already have a denominator 4, and so no equivalent needs to be found. The sum of the whole numbers is 5, and now let us go to adding the proper fractions, that is 3 by 4 plus the equivalent of 1 by 2, that is 2 by 4 plus 1 by 4. So now the 5, that is the sum of the whole numbers, let us keep it as such and add the proper fractions. 3 plus 2 plus 1 by 4, which is 6 by 4. Now 5 plus 6 by 4. 6 by 4 is an improper fraction, but we know that a mixed fraction consists of a proper fraction. So we need to convert this improper fraction into a mixed fraction. So let us do division. Let us divide 6 by 4. We will get the remainder as 2, the quotient as 1, and the denominator or the divisor as 4. So now let us arrange these in the form of a mixed fraction. The sum of the whole numbers 5, let it be as such. 6 by 4 improper fraction is written in the mixed fraction form as 1 2 by 4, where 1 is the quotient, 2 is the remainder, and 4 is the divisor or the denominator. Now let us add these both. 5 plus 1, where 1 is the whole number of the mixed fraction obtained just now, plus 2 by 4. 2 by 4 can be cancelled in the 2 table and we get 1 by 2. Adding 5 and 1 we get 6. So adding these two we get 6 1 by 2, which is the required answer. So now let us see the second method. That is, let us convert the mixed fractions into improper fractions and then add them. Converting the mixed fraction 2 3 by 4 into improper fraction, we get 11 by 4. And the improper fraction of the next mixed fraction 2 1 by 2, we get it as 5 by 2. Similarly, for 1 1 by 4, we get the improper fraction as 5 by 4. Now let us add these three improper fractions, that is 11 by 4 plus 5 by 2 plus 5 by 4. These three fractions have different denominators. Their LCM is 4. Now let us find an equivalent fraction for 5 by 2. The equivalent fraction for 5 by 2 which we have got is 10 by 4. The other two fractions already have a denominator 4, so they can be taken as such. So we get 11 by 4, replacing the equivalent fraction of 5 by 2 as 10 by 4 plus 5 by 4, which we get it as 11 plus 10 plus 5 by 4, which is equal to 26 by 4. This is an improper fraction. So let us convert this improper fraction into mixed fraction. We need to perform division. On dividing 26 by 4, we get the quotient as 6 and the remainder as 2. Arranging this in the form of a mixed fraction, we get 26 by 4 is equal to, the divisor 4 comes in the place of the denominator, the quotient 6 comes in the place of the whole number, and the remainder 2 comes in the place of the numerator. So the mixed fraction we have got is 6 2 by 4, reducing which we will get 6 1 by 2, which is the required answer, and the answers we have got with both the methods are the same. Now let us move on to the exercise problem, the second subdivision of the third problem. We have 3 1 by 3 plus 4 1 by 6. Now let us add the whole numbers separately and the proper fractions separately. That is 3 plus 4 plus 1 by 3 plus 1 by 6. The LCM of 1 by 3 and 1 by 6 is 6. Finding an equivalent fraction for 1 by 3, we get 2 by 6. And 1 by 6 already has a denominator 6, so we can keep it as such. Now the sum of the whole numbers is 3 plus 4, which is 7. And adding the proper fractions, we need to replace the equivalent fraction in the place of 1 by 3. That is 2 by 6 plus 1 by 6. We can take the sum of the whole numbers as such 7, and the sum of the proper fractions we get 2 plus 1 by 6, which is 3 by 6, and reducing which we get 7 plus 1 by 2, which is equal to 7 1 by 2. This is the required answer. Now let us move on to the sixth subdivision of the third question. The question given to us is 7 2 by 7 minus 3 4 by 21. Similar to addition, let us subtract the whole number separately and then subtract the proper fraction separately, and then let us add both the resultants. Subtracting the whole numbers 7 minus 3 and subtracting the proper fractions, that is 2 by 7 minus 4 by 21. The LCM of 7 and 21 is 21. Finding an equivalent fraction for 2 by 7, we get 6 by 21. 4 by 21 already has a denominator 21, and so it can be kept as such. The difference of the whole numbers is 4, and to find the difference of the proper fractions, we replace the equivalent fraction, so we get 6 by 21 minus 4 by 21. The difference of the whole numbers we have got is 4, and the difference of the proper fractions we have got is 6 minus 4 by 21, which is 2 by 21. And adding these both, we will get 4 2 by 21, which is the required answer. 7 from the same exercise. From the data given, the amount of tomatoes purchased is 3 1 by 2 kg. The amount of brinjal purchased is 3 by 4 kg, and the amount of onion purchased is 1 by 4 kg, and we are asked to find the sum of the vegetables. Let us go with the second method. Let us convert the given mixed fractions into improper fractions. Converting 3 1 by 2 into improper fraction, we get 7 by 2. The next fraction given to us is 3 by 4, which is not a mixed fraction. It is already a proper fraction, so we need not convert it and we can take it as such. The third fraction is 1 by 4. Converting this fraction into an improper fraction, we get 5 by 4. Now, adding these three resultant fractions, we will get 7 by 2 plus 3 by 4 plus 5 by 4. The LCM of their denominators is 4. An equivalent fraction for 7 by 2 is 14 by 4. The other two fractions already have a denominator 4, so they need not be found an equivalent fraction. Now, replacing the equivalent fraction for the first fraction, we get 14 by 4 plus 3 by 4 plus 5 by 4, which is equal to 22 by 4. This is an improper fraction. Let us convert it into a mixed fraction. On dividing 22 by 4, we get the quotient as 5, the remainder as 2, and the divisor is 4. Arranging these in the form of a mixed fraction, we get 5 2 by 4. On simplifying this in the two tables, we get 5 1 by 2, which is the required mixed fraction. So the total amount of vegetables purchased is 5 1 by 2 kg. Now let us move on to the 8th problem. An oil tin contains 3 by 4 liter of oil. In this oil, 1 by 2 liter of oil is used. So we need to find the remaining. For that, we need to find the difference of these two. The difference of these will give us the remaining oil in the tin. Let us go with the second method. Let us find an improper fraction for 3 by 4. We will get 15 by 4. And finding an improper fraction for 1 by 2, we will get 5 by 2. Now let us find the difference of these two improper fractions. That is 15 by 4 minus 5 by 2. The LCM of these two fractions is 4. Finding an equivalent fraction for 5 by 2, we get 10 by 4. Replacing this equivalent fraction, we get 15 by 4 minus 10 by 4, which will give us 5 by 4. This is an improper fraction. Let us now convert this improper fraction into a mixed fraction by performing division. Dividing 5 by 4, we will get the quotient as 1, the remainder as 1, and the divisor is 4. Arranging this in the form of a mixed fraction, we get 1 by 4. This is the amount of oil left in the tin, that is 1 by 4 liter. So hope you all understood today's class well, children. Let us meet in the next class. Thank you.